Prakash, start ಮಾಡಿ.
Start ಮಾಡಿ. Good evening to all of you. Am I audible?
Yes,
Hello?
sir. Yes, sir. Yes, sir. You are audible.
Yes.
I have a great pleasure to welcome you all to this QCrete International webinar on low carbon concrete. On behalf of Indian Concrete Institute Mangalore Center and QCrete Readymix India Private Limited, I wholeheartedly welcome today's speaker, Mr. Richard P. Kershaw, Technical Manager, CIMEX UK, CIMEX West Europe. I welcome you, sir.
Well, thank you very much, and I'm really pleased to be able to present to you this afternoon in the UK and obviously this evening in India time.
I extend my warm welcome to Engineer Shelley S. Fernandez, MD, and Engineer V.R. Kaushika, Director, QCrete. Welcome you, sirs.
Thank you. Thank you, sir.
I welcome Professor Hemant Prabhu, Secretary, and Engineer Anil V. Baliga M, Treasurer, ICI Mangalore Center. I welcome you, sir. I extend my warm welcome to Anjali Madam. Madam, I welcome you. I welcome all the members and representatives of QCrete and ICI Mangalore Center. Last but not the least, I welcome all the participants. I welcome you all. Over to MC.
Thank you. Thank you. Myself, Kaushik from QCrete Readymix, have the honor of introducing our speaker for today's webinar. I can say it is a privilege for our company to be hosting an expert from UK. We are extremely thankful to Mr. Richard Kershaw for accepting to do this webinar. Mr. Richard P. Kershaw is working as Technical Manager, CIMEX UK, CIMEX Western Europe. Mr. Richard Kershaw has been employed in technical and quality management field for over 30 years and has been involved in many large construction projects during this time. He has been involved in the development of many innovative products, including high performance self-compacting concrete, low carbon products, and dry silo sprayed concretes. He is responsible for a team of specialist technical managers who focus on product conformance, technical guidance, and product innovations. Richard is an experienced manager and is constantly striving for improvements in all aspects for which he is responsible. Having responsibility for the technical department within the concrete and aggregate businesses, he is able to impact improvement at every stage, from production through to contract completion. Richard sits on a number of BS and EN committees. Most importantly, Mr. Richard Kershaw readily accepted to do the presentation when we approached him. We are also thankful to all the audience who have come here at this moment to hear from Mr. Richard Kershaw. I welcome our MD. I welcome all the office bearers, including the chairman of Mangalore Indian Institute of Concrete Institute Center. Thanks, and it is over to Mr. Richard Kershaw. Thank you.
Okay, well, many thanks for the warm welcome and thanks for the kind introduction. Good evening, everybody. And as I say, many thanks to QCrete Readymix and the Indian Concrete Institute for the invitation to present and discuss lower carbon concretes with you this evening. My particular thanks to Kaushik. He's been a great help working with me on the title, the content, and of course making sure that the IT systems work. So many thanks to Kaushik for this. As the introduction, I'm Richard Kershaw. I'm technical manager for CEMEX UK, part of CEMEX West Europe, and I'm responsible for aggregates, concrete, mortar, screed, and dry silo products, both from a product development point of view and also from product conformity. Just so you know, I'm broadcasting this from Nottingham in England in the UK. So when I press the slide to change, there may be a slight delay before you see it, but if there's any problems, we do have a backup kindly organised again by Kaushik. So we will move into the presentation. So already, okay, so already the presentation has frozen, Kaushik. Can you hear me?
Yes, sir. Yes, sir.
Please change Anjali, madam.
Yeah, the presentation is frozen. I've tried to press the next slide and it's frozen.
She will change, sir. Anjali will change.
Yes, sir.
Okay.
Yes, sir. I'm changing now.
Sure. Apologies for this. We suspected this may happen. Maybe if I switch off my webcam, that may help. Okay, so I'm giving control back to you, okay?
Yes, sir.
Okay. Okay, are you able to move to the next slide?
Sir, have you given me the control?
I have, yes, yes. Okay, you should have control now. Okay, that's excellent. So yeah, that slide is fine. If you could put it onto slideshow for me.
Yes, sir. Yes, sir. Sure, sir.
Sure. There we go. Okay, that is excellent. Thank you very much for help, and apologies for the problem with IT already. So as I say, good evening, everybody. Thanks to QCrete and the Indian Concrete Institute for the opportunity to discuss. If we go to the next slide. Okay, great. So the content today is going to be outlining the benefits of concrete, following a brief introduction to CEMEX. Highlight how changes to specification, the design of concrete structures could perhaps lead to a more sustainable construction. Look at the current narrative that's happening in the UK with regards to sustainable construction. Review raw materials used in the production of concrete and how these impact on the embodied carbon per cubic meter. Discuss low carbon concretes in general and how the launch of CEMEX's Virtua range of concretes looks to simplify specification and the benefits of offsetting to achieve net zero concrete. And then look at case studies of recently supplied Virtua concrete. So, again, to emphasize, this is quite European and UK focused, but I think the thinking behind low carbon concretes, the thinking behind how to develop low carbon concretes really translate across all countries. So in terms of an introduction to CEMEX, if you could go to the next one, please. Thank you. So next one again, sorry. Thank you. So Cemex, we were founded in Monterrey in Mexico back in 1906, and since then we've grown into one of the top global companies in the world. We've 40,000 employees across 50 countries, and our turnover is circa $15 billion per annum. We've over 1,400 concrete plants across the world, and we've sales of 50 million cubic meters of concrete, and we are the world's leading supplier of ready-mix concrete. And as you see on the slide, we are primarily a cement business. Concrete, we've quarries, 130 million annual tons, and then distribution centers, marine terminals, etc. So this is Cemex as a global organization. If we could then move on to the next slide, where we'll look a little bit about Cemex in the UK. So Cemex in the UK, we operate a comprehensive national supply network, really to ensure that the quality materials and services are available to our customers locally. In addition to ready-mix concrete, cement and aggregates, we also supply and install asphalt products, manufacture concrete block pavings, rail products, bespoke precast products, and also concrete blocks. And I think importantly, from a sustainability point of view, all of our ready-mix operations, so all of our concrete production facilities, use responsibly sourced raw materials in line with BRE BES 6001. What does that enable us to do? Well, BES 6001 enables our products to gain credits under various assessment schemes. So whether that's BREEAM or CEQAL, it's all about improving the sustainability credentials in public and civil engineering projects. If we go to the next one, please. So this is about the concretes that we are currently developing and innovating within Cemex, where what we've done is look to focus on a particular construction activity. So that might be the aesthetics of a building, that might be the setting times of the concrete, where we're looking to slow or speed up the setting time of concrete for different applications. Different placing techniques leading to improved surface finishes, and of course change the properties of the concrete as well. So for example, amending the density of the concrete to make it lighter or heavier depending on the application. And this next slide shows a video of some of the innovative concretes that Cemex are currently producing. So we'll just let this run and you can enjoy some of our concretes. I think that video is frozen. Could you try to run the video again if possible?
Yes, sir. Yes, sir.
If possible, yeah. If you just go back up a slide and then come back, it should run automatically.
Yes, sir. I'm trying now.
Sure. Okay, that's excellent. Thank you for that. Okay, I think we're struggling with the video. Oh no, we're back up and running. Okay, that's great. Apologies, it was a bit of a truncated video, but hopefully you got the flavour of the different types of concretes that are being developed by Cemex. There's fibre reinforced, there's lightweight, there's heavyweight, there's flowing concrete. So as I say, hopefully you got the flavour of that. If you go to the next slide, please. So this is about just an overview of concrete and the benefits of concrete as we see it from a UK supply point of view. So if you could move on to the next one, that would be great, please. Okay, thank you very much. So, you know, concrete to me is the most important manufactured material. Okay, so both in terms of the sheer volume that's produced each year and the positive impact that it has on regional economic development. And I think we're certainly seeing that, you know, in the Indian construction industry with the huge developments that are taking place, particularly around infrastructure and road building. You know, in the UK, concrete is vital for infrastructure that helps provide us with clean water. We've got a very large project called the Thames Tideway project. Low carbon energy. We've got a new nuclear power station being built in the southwest of the country called Hinkley Point C, as well as, of course, durable homes, schools, hospitals, and importantly, railways. I mean, our largest infrastructure project in the UK is HS2, development of a high-speed railway between London and the Midlands, which is taking significant volumes of concrete. We're supplying one particular stretch of that contract, which is around 400,000 cubic meters of concrete. If we can move on to the next slide, please. I think that, you know, the real benefits with concrete are, you know, and I think this again translates across all countries. It's local and readily available. Short travel distances from the production facility to the job site, and of course that has an impact on carbon. It uses responsibly sourced materials. Okay, it can be bespoke design, as we saw from the film, for really any shape and application. You know, for example, we can design it with early age compressive strength, set retardation, and consistent retention to make the concrete life a lot longer. And of course, it can even be delivered with its own reinforcement in the form of steel fibers. If we go on to the next one, please. It's energy efficient. It's got many performance benefits. Okay, with regards to energy efficiency, its thermal mass benefits. It absorbs and retains heat. It therefore, you know, it's really got a proven role in reducing the energy associated with the heating and cooling of a building, and of course therefore has the potential to reduce or even omit the need for air conditioning. Again, all very important if we're looking about the carbon for the whole build. It's fire resistant. It doesn't create smoke, emit fumes, or fuel a fire. It has flood resilience, adding to coastal and river defense measures. It's 100% recyclable. So again, if we think about circular economy, if we think about associated carbon, we can recycle 100% of our concrete and look to reuse it either back into concrete or in other applications. It's very low maintenance. It doesn't rust or rot. Importantly, it's a consumer of waste. So again, if we think about circular economy, it consumes waste in terms of recycled aggregates, crushed concrete aggregates, fly ash and GGBS, and thus keeping those materials out of landfill, but also reducing the need for primary aggregates. Okay, moving into what we can do in the short term with regards to reducing concrete. Now, I think as an industry, we need to look how concrete is specified in order to make construction more sustainable. Certainly in the UK, there's over specification of concrete. Many design margins are being added to a structure. So we have a client engineer who has an idea of concrete strength. He then gives that to my customer. My customer then potentially adds on an extra over design margin. And of course, as a concrete supplier, I'm adding on my own design margins to meet the specified compressive strength. In terms of design lives, designing concrete structures for increased longevity, including built-in flexibility for changes of use, hopefully resulting in the reduction in the demolition of buildings. Certainly we're seeing in London, buildings that are only, say, 20 years old are being demolished to make way for future developments, and all that has an impact on carbon. But can we be even more innovative when designing structures? I'm involved in a project here in the UK called Resilient Materials for Life, which is looking at self-healing concretes to reduce the amount of reinforcement that's primarily required to control crack widths. That leads to a reduction in maintenance costs and therefore prolong the use of the structure. So it's RM4L, Resilient Materials for Life. It's available on the internet. It's a collaboration of Bath, Cardiff, Cambridge and Bradford universities, and they're working with an industrial advisory board of which CEMEX are part of. If we look at compliance periods, most specifications that we receive in the UK will have a compliance period for the test specimen cubes here at 28 days, which leads to particular binder contents. Should we be looking at 56 or 90-day compliance in order to really best optimize concrete mix designs through the increased percentage additions, fly ash, GGBS? Of course, recognizing that this may have an impact in terms of build program, takes longer to cure, stripping times of formwork are therefore increased. Near the bottom there, high performance concretes and perhaps promoting higher performance concretes that need increased binder contents is perhaps contradictory if we're talking about low carbon concretes. But if we cast columns, walls, slabs with higher performance concretes, higher compressive strength concretes, could that lead to thinner sections and therefore lead to a reduced total volume of concrete? Reduced total volume of concrete should equate to a reduced CO2 for the build. So we're talking here about high performance greater than 60 MPa at 28 days, fiber reinforced basalt fibers, graphene reinforced concretes. And then finally, certainly perhaps one for the future, specifying a target CO2 per cubic meter would perhaps focus all parties on reducing the embodied carbon per CO2. So if we look at the current narrative, if we just flick on a couple of slides, please. And again, if you can. Lovely, thank you very much. So these are some of the headlines that we're seeing in the UK. So there is discourse around climate change and the impact that the construction industry has on global warming. That's really thrown particularly cement and obviously then concrete production into focus, with my customers, specification professionals, very concerned about how suppliers can help them achieve their sustainability goals, whilst ensuring, of course, that structures remain functional, safe, and aesthetics. And we've seen some major players in the construction industry in the UK publish their sustainability targets. Mace, who are a very large contractor, their target is to be carbon neutral. And we've seen Laing O'Rourke as well, a major construction company here in the UK, launch its own sustainability targets where they want to be operationally net zero by 2030. And Ray O'Rourke, Mr. Ray O'Rourke, who is the group CEO, he recognises that the construction industry has some very difficult challenges to solve. And he highlights carbon in concrete and carbon in steel reinforcement. He highlights both of those products as being an area of concern and challenge for his business. If we go to the next one, this is about HS2. So HS2, High Speed Railway 2, you know, as it says there, you know, this aims to be the most sustainable railway in the world. It's certainly looking to drive innovation, both in design, construction, and operation to minimize its carbon footprint. Now, HS2 with phase 1, so that's all about tunnels, viaducts, stations, and railway systems, is looking to reduce its carbon by 50%, which is quite a challenge. And a gentleman called Peter Miller, he's the environmental director for HS2. You know, his recent comment was the fact that, you know, climate change he sees as is the greatest long-term threat to Great Britain's security and prosperity. You know, the UK government has set a target for net zero emissions by 2050, and we want to see that HS2 is playing its part in meeting that challenge by using innovative techniques and products in the construction of the new high-speed railway. And, you know, his comment is we can only build HS2 more sustainably, but lead by example by showing the rest of the construction industry how we can deliver. So the opportunity here is all around collaboration between specifiers, manufacturers, in order to achieve the 50% reduction, and as I say, the government's target of net zero by 2050. So that's a bit about the background information to CEMEX and the background information to how we all love concrete so much, and the current comments that are taking place within the UK construction industry. So the next series of slides now will look at raw materials. If we could just move on to the next one. Great. So raw materials, you know, I think we all know on the call that concrete is pretty much made up of 3 main constituents, with typical mass proportions of coarse and fine aggregate. That takes up to about, what, 70 to 85% of concrete mix design. Our binder, our cement, our additions, 10 to 20%, depending on the specification. And very importantly, water, of course. You know, as I always say, you know, you can't make concrete without using water. And at this point, we're about 3 to 10% of our mix design is made up by water. Of course, we have other materials. We have admixtures, we have fibers, we have viscosity modifiers that make up our concrete, and we'll touch on those in the next few slides. But I think from a raw material point of view, it's really important to remember that around 80%, 75 to 80% of the embodied CO2 is associated with the production, with the production and supply of concrete is down to the cement. It's down to the ordinary Portland cement, the PC, the CEM1 that is used in our concrete, 75 to 80% of the embodied carbon. So the challenge for the industry is about how do we decarbonize the production of CEM1. And as we move through the following slides, they present and discuss each raw material. So perfect. So aggregates. Aggregates are the major, sorry, go back up one if you could. Aggregates, yeah, great, thanks. So aggregates are the major component of concrete, as we've talked about, 70 to 85% by volume, and they're low carbon. They are inherently a low carbon product. Typically less than 10 kgs of CO2 per ton is associated with aggregates. Most aggregates we use, certainly in the UK, are naturally occurring, requiring very little processing, and they're usually locally sourced. So there's an associated benefit there in terms of low production CO2 and low transport CO2 emissions. And BSEN 12620, aggregates for concrete, you know, that does not discriminate between different sources of material. It permits aggregates from natural, recycled and manufactured sources. So the next slide, if we can, that looks at recycled materials. And, you know, here in the UK, we really lead Europe in recycling recycling rates for hard demolition waste and sources of recycled aggregates and crushed concrete aggregates, and also secondary aggregates are utilised in the construction industry. Now, The concern really is, depending on the type of recycled, crushed or secondary aggregate used, there may be an increase in water demand, and therefore a need to increase the total cement content of the concrete to achieve the specified characteristic strength, with of course a knock-on increase in embodied CO2 content. So, you know, really when assessing the broader sustainability aspects, it perhaps will, in many cases, prove to be better if recycled materials, the demolition waste, is used in other applications, you know, perhaps in lieu of primary aggregates, put into fill materials, and keep primary aggregates for their use in concrete. So for me, recycled aggregates, in summary, you know, when they are being specified, there's a number of factors to balance. Resource depletion, understand that. The potential increase on processing and transportation, and the implications on concrete mix design, leading, as I say, to an increase in embodied carbon. So in terms of cements, you know, from quarrying the raw materials, heating of the kiln, grinding to produce the finished product, making cement, as we know, is an energy intensive process, and it represents the majority of the embodied CO2 in concrete. As I say, typically around 75 to 80% of the embodied CO2 in concrete is coming from our cement. However, you know, I think it's important to remember that global cement production is responsible for what, 7-8% of the global CO2 emissions. Here in the UK, our emissions are amongst the lowest in the world, at less than about 1.5% of all UK emissions. How are we achieving that? Again, I'm talking about Cemex UK. We reduce our clinker factors in our cement plants by the inclusion of fly ash, GGBS and limestone during the production. We use alternative raw materials, for example, recycled plasterboard, the reuse of cement kiln dust and foundry sands within the production of cement. We also use waste-derived fuels instead of virgin fossil fuels, and typically around 60% of our total fuel use is actually from waste-derived fuels here in the UK. I'm pleased to report that you know, these initiatives adopted by Cemex Cement here in the UK have resulted in a reduction in CO2 emissions of around 40% since 1990, which is obviously a significant number since 1990. So if we move on to the next slide, please, we'll talk about additions and how they can lead to benefit in lowering CO2. So, you know, additions are generally byproducts from other industries, blended with CEM1 to improve the plastic and hardened performance of the concrete, perhaps increase the recycling content, but more importantly, reducing the embodied CO2. As previously mentioned, the use of these secondary materials uses products that might otherwise be disposed into landfill. And in the UK, there is a long track record of using products like GGBS, a product from the production of iron, and fly ash, a byproduct from the burning of coal in power stations. But more importantly, we're looking at other materials, silica fume and limestone fines and calcine clays, natural pozzolans as well, that can be added to form different cement combinations and reduce the embodied CO2. So we've had aggregates, cement and additions, and we move on now to admixtures. So if we could go to the next slide, please. Thank you. Yes. So admixtures, very important for positively affecting both the fresh plastic properties of concrete, but also the hardened properties as well. You know, in a fresh state, making the concrete easier to handle, which perhaps saves time and reduce resource on site if we think about self-compacting concretes. And I guess a good example of the use of admixtures is water reducing admixtures, be it a standard WRA or a super plasticizing admixture, which enables a concrete at a given strength to have a lower cement content, a lower water cement ratio, and thus reducing the embodied CO2 whilst continuing to enhance the concrete's performance. So something as simple as the use of a water reducing or super plasticizing concrete to reduce the total binder content has a positive effect on the embodied CO2 of the concrete. If we can move to the next one, please. So you know, I think perhaps sometimes an overlooked option for saving the overall embodied carbon in a structure is the reinforcement. You know, steel reinforcement is a high emitter of carbon. You've got the on-site placement of reinforcement with resource required to place, to cut, to move the steel, which is obviously very time consuming and quite laborious. The opportunity really is to look at fibers which can be added at point of production. You know, they work in a very similar way to the mechanism of crack interruption to steel. And there's excellent benefits, as we see with steel fibers, in terms of increases in tensile strength and ductility. And the next slide, please, which will show the kinds of innovative materials put to practical use. So this is a steel fiber reinforced concrete with fiber content in excess of 100 kgs per cubic meter. It was used in the construction of a concrete house, which was filmed as part of a program called Grand Designs here in the UK, and we saw around 60% of the total original reinforcement replaced with steel fibers, which saved an awful lot of time. And the video clip you can see in the corner, that's a self-compacting, high-performance fiber reinforced concrete. That's probably flowing around about 6 linear meters to cast a wall. So, sorry, next slide, please. So if we think about low carbon concrete, and if we can move quickly to the next slide, you know, one of the issues that we see is there's currently no value defined for the embodied carbon per cubic meter that would qualify a concrete in the UK as being classified as low carbon. Okay, so that's one of the challenges for the industry. What we use here in the UK, the comparator typically used is the specified concrete against the standard CEM1 Portland cement concrete. The key really is, first of all, we need to get a number which is classified as low carbon, and we're seeing that with some of our clients now, looking at compressive strength and targeting an embodied carbon per cubic meter. But the key to me is the fact that it's really, really important to note that lower carbon concretes are available today using cement designations, and as we've discussed, utilizing admixture technology that are included in design codes and material standards. So it isn't about alkali activated cementitious materials, geopolymers, clinker-free products solely. There are cement designations available today which are lower carbon. So that takes us nicely into the next slide, which are extracts from British standards. So the tables to what I'm looking at is my left. These are extracts from BS 8500 Part 2. The table to the right, table 1, is from the BRE IP 1705, which looks at concrete with high percentage GGBS for use in hard and firm secant piling. All of these show cement designations with higher percentages of GGBS and fly ash using CEM1 as an activator. And what these will do is typically reduce the embodied carbon by 30 to 70% against the CEM1 concrete. And these are cement designations that are available in British standards now. Next one, please. Thank you. So, sorry, press again. Yep, excellent. So this is about what we're doing as CEMEX UK and as a global organization. So, you know, our purpose, CEMEX's purpose, is all about building a better future. And, you know, perhaps unsurprisingly, you know, we believe that concrete remains an essential part of construction. We obviously recognize that construction needs to be a balance with the effect that it has on the environment. And at CEMEX, we know we can best meet these challenges by working with clients and key stakeholders to innovate, as we saw from the video clip, and continue to develop low carbon solutions together. And the togetherness is really key to us. We continue to invest in all of our operations to reduce carbon. As I said earlier, we've reduced the CO2 emissions in clinker production in the UK by around 40% since 1990. We continue to reduce the clinker factors with about a 30% clinker substitution in our cement production. 100% of all our operations in the UK are supplied with renewable energy. So that's our offices, our laboratories, our concrete plants, and obviously our cement works as well. And we've targeted a 55% reduction in CO2 levels in concrete by 2030. And the bottom of that slide there gives us an indication of some of the projects that we're looking at in terms of continuing to reduce the carbon associated with our business. If we go to the next one, please. Thank you. So we launched what we call our Virtua range of low carbon concrete in March 2020. Here in the UK, as around most of the world, COVID hit. So it was launched, circa 10 to 15 days before the UK went into lockdown. So it's quite a memorable time to launch the product. And we were really proud to have developed the UK's first range of ready-mix concrete that could be supplied as carbon neutral. And I'll touch on what carbon neutral means for us in the UK in the following slide. So if we move on to our Virtua range of low carbon concretes. Excellent. So Virtua is a range of low carbon concretes. Each one is bespoke designed to meet our customers' requirements and importantly reduce the embodied carbon per cubic meter. The range has other benefits, including increased durability, aesthetic finishes, and reduced heat of hydration. And the slide here gives you an indication of the types of reduction in CO2 that you can achieve when using these concretes. So if we just move into the next slide, which we'll discuss Virtua Classic. So Virtua Classic is our entry level concrete. It can be designed to use in most applications, from very simple strip foundations to industrial floors, with compressive strengths of up to C4050 MPa, and typically has a 30 to 50% reduction in CO2 when compared to a standard CEM1 concrete. If you move to the next one, please. Thanks. So Virtua Plus, really that's primarily designed for geotechnical applications, piling, diaphragm walls, mass foundations. It has the added benefit in mass concrete structures in terms of reduction in heat of hydration. It meets the requirements of design chemical class 4, which is a very onerous sulfate ground condition, and typically has a 60% reduction in CO2 when compared to a standard CEM1 concrete. Go to the next one, please. So Virtua Ultra Zero, this is our innovative geopolymer, clinker-free, alkali-activated cementitious material. It's available on request in the UK for bespoke applications, and it is only offered with the offset option. It has a reduction of around 70% when compared to CEM1. And whilst the Virtua Classic and Virtua Plus both conform to BS8500, utilize cement designations that are listed in BSEN 206 and BSEN 197 Part 1, currently all alkali activated cementitious materials, geopolymers, clinker-free binders are not currently listed in product or design standards, but they can be supplied with agreement, which is why I say that it's important to recognize that low and lower carbon concretes can be delivered utilizing cement designations that are accepted in standards. It doesn't have to be around novel or niche cements. So that's our Virtua range of concretes. like to just to show everybody. That's okay. Yeah, keep going down. That's excellent. Thank you. And again. Would it go again? If you just go to the next one, please. That's it. That's excellent. Thank you very much. So a little bit about the virtual contracts that we've supplied. So we were really proud and pleased to supply our virtual range of lower carbon concrete into foundations in Brighton in the southeast of the UK. It was for a slab, and this was the first carbon neutral concrete supplied in the UK. We've supplied projects for Warwick University, HS2, as we talked about, High Speed 2, the railway in London, and a project in Leeds. And hopefully the next slide and film shows the supply of the concrete to a head office building in Leeds. So if you go to the next slide, the film should run automatically. Okay, you may need to click into the slide. There we go, thank you. So this film clip just gives you an overview of the supply from our Leeds plant in the north of the UK. Just really gives you an indication of the types of applications that we're supplying lower carbon concrete into. So that's our concrete plant in Leeds. I'll be interested to hear from people on the call how a concrete plant in the UK compares to a concrete plant in India. This is one of our more high-profile, higher performing plants that would typically do around 500 cubic meters per day across a range of projects. Would have around 8 or 9 concrete plants based there per day. This is our virtual low carbon concrete. What I always tell people is it looks and it smells and performs the same as any other concrete. You see it pumps very well. It's very easy to place. So that's a range of the low carbon concretes. And again, apologies if that video didn't run particularly well. So these are 3 projects where we've supplied our cement-free, our clinker-free cement concrete. So we've supplied precast projects in both Durham, up in the northeast of the UK, and at Bradford University, where we're working together with them to look at some precast slabs. And pleasingly, we also supplied a project in London, which may have only been blinding for foundations, but it was quite a high profile office and mixed-use development in the capital. If we move to the next slide, please, this just gives us an overview of offsetting. And the next one, please. Thank you. So in order to produce a net zero concrete, then we have to offset the residual CO2. And carbon offsetting is the purchase of carbon credits from projects that deliver immediate emission reductions. Cemex customers across the world are able to offset any residual CO2 in our concrete supplied through Cemex's partnership with a business called Natural Capital Partners. Natural Capital Partners have about 20 years experience and work with about 300 companies in in 30 plus countries. They work with people like Microsoft and Sky and UPS in order to offset CO2 in their businesses. We currently work with natural capital partners that on projects that physically remove CO2 from the air. So we're looking at tree planting in East Africa, and these are done through independently and audited projects. We're also reviewing other options, such as, I don't know, conserving forests, replacing fossil energy with renewable energy. So these are all options that we have open to us to carbon offset the product. And what's really, really important is we can only purchase carbon credits that are accredited under what's called the gold standard or the verified carbon standard. And we, again, can only offset products where we have demonstrated that we have optimized to reduce the embodied carbon. So we cannot supply concrete in 100% CEM 1, Portland cement, OPC, because we've not optimized that design. We have to use admixtures, we have to use fly ash and GGBS to demonstrate that we've reduced the embodied carbon to enable us to offset with natural capital partners. Other services that we provide, if you go to the next one, please. So we locally, so in the UK, we're really managing and reporting the measured CO2 in our concrete using third-party verified CO2 tool, verified to PAS 2050. So this tool is best used again when comparing the embodied CO2 of the specified concrete versus the optimized supplied Virtua concrete. And these certificates, as you see where it says Readymix carbon footprint calculation, these certificates are available to all of our customers upon request. And on the right there, that's just an example of a web-based tool which enables the customer to get an overview of the reduction in carbon that they would get by specifying Virtua, our low carbon concrete. If we move to the next one, please. So these are publications. These are available on the web, and I would really urge everybody on the call to review and look at some of the Mineral Products Association, the Decarb Nation and Specifying Sustainable Concrete documents. And 2 weeks ago, we launched through the Green Construction Board in conjunction with the Institute of Civil Engineers and the British Standards Institute. We produced and published our low carbon concrete route map, and I'm quite happy to share a link of that, a link to that document to Kaushik, if he can, share that with the delegates on the call. There's no problem with that at all. So next slide, please. We're coming to the end. You may be pleased to know. So in summary, Cemex Materials, we're looking to support sustainable construction through that early age engagement with our customers, looking at design optimization of the concrete, looking simply at admixture use, yes, to a degree of offsetting because of the need to produce a net zero concrete, looking at compliance periods, as I touched on earlier, moving from 28 to 56 to 90-day compliance. The measuring and reporting of concretes is really important, and our Virtua range of concretes as well. Next one, please. Thank you. So a reminder, concrete is an essential sustainable building material that supports the economic development, across the world. There is a need for collaborative change in design and specification, where elements can be optimized through design margins, perhaps through geometry, maybe even procurement to make sure that the embodied CO2 is included throughout the supply chain, and importantly, measure and report as well. We were proud as Cemex to be the first company to launch net zero ready-mix concrete in the UK. Virtua is a range of low carbon concretes, but it's only an interim solution while we look to decarbonize the emissions associated with the production of cement. And really importantly, Cemex have committed globally to net zero emissions in concrete by 2050, which is which is very much approaching. So next slide is a reminder of us all of how important ready-mix concrete is to our world. You may have to click in the, yeah, there we go. Thanks. So these are some examples where concrete is used. Some of these are CEMEX projects, and again, it highlights how important concrete is in our everyday world and the continued development of infrastructure, as we see there with railways to cities for prosperity, safe places to live, safer from the environment in terms of flooding and the impact on climate change, to education, obviously there to hospitals as well, and importantly to somebody from the UK, football stadiums. The innovation of concrete, as the first film showed, with some of those highly innovative concretes, as we saw, from the ability to see the Mona Lisa on a piece of concrete when it gets wet, through to some very thin sections from fibre reinforced, to what's clearly important and the subject of today's talk around reducing embodied CO2 per cubic metre of concrete, with the Virtua range, which, as I say, looks and tastes and smells just like standard concrete. Okay, so that ends the presentation. Thank you again to QCrete and the Concrete Institute from India for the kind invite to allow me to speak to you this afternoon. It's been a real pleasure and an honour to present to you. As a final point, I think early age engagement between clients, between specifiers, concrete producers, will help increase the demand for low carbon concrete and further drive investment into solutions, because invariably it's all about decarbonising the production of cement, and that takes investment to enable us to do that. So again, thanks again. It's been a real pleasure to be able to present to you. The final slide gives an opportunity for questions and feedback coming back into the technical department from QCrete, and then you have Kaushik's email address there if there's any questions. I don't know what the format is now, Kaushik, whether there's an opportunity for some discussion, maybe?
Yes, sir. We have got some questions,
Yes,
and I'll read out one by one.
Okay, excellent.
So the first question is, do you charge more to low carbon concrete against normal concrete? And that was asked by Mr. Gunashekaran.
Okay, well, thank you very much for the question. So if we look at the clinker-free, cement-free concrete, the Virtua Ultra Zero, that does come with an increase in costs by around a 50% uplift. In terms of the offsetting option, and I'll speak in English pounds, that's typically around £3 to £5 per cubic meter extra solely for the offset. But if we talk about the true innovative low carbon concretes, that's about 50% uplift.
Thank you so much, sir. The next question is, how much use of geopolymer concrete in reducing carbon dioxide, CO2? And that was asked by Radha Krishnan.
Okay, well, thanks. So was the question about the percentage reduction in carbon or the volume used?
Percentage reduction in carbon, sir.
Reduction in carbon. So, okay, around 70 to 80% if using a geopolymer compared to CEM1, that is. So if you're comparing it to a concrete that already contains an addition, then obviously that is slightly lower, somewhere between 40 to 50%, but you're talking about 70 to 80% reduction when compared to a CEM1 Portland cement type 1 cement.
Thank you so much, sir. The next question is, what is the minimum cement content for structural concrete in Europe? Let us say C25, and that was asked by Mr. Raghu.
Oh, okay, thank you. So obviously depending on the application, but for protection to reinforcement, the minimum cement content, that's total cement content, so not just the CEM1 type 1 proportion, is 240 kgs of cement per cubic meter. But typically we would see most structural concretes, columns, walls, slabs having minimum cement contents of 320, 350 kgs per cubic meter.
Thank you so much, sir. The next question is, when we use recycled aggregate in the concrete, how about the concrete strength? And that was asked by Mr. Shrikant HV.
Okay, again, thank you very much for that. So if we're using recycled aggregates from demolition waste, then I would expect the water demand to be increased because it's a poorer quality material generally. And I think that would lead to an increase in cement contents to achieve the equivalent compressive strength of around 30 to 40 kgs per cubic meter of total binder to achieve the same strength. So your cement content is going up by 30 to 40 kgs. And of course, that's increasing your embodied carbon per cubic meter as well.
Thank you, sir. The next question is, at what temperature is low carbon concrete suitable? And that was asked by Mr. Sheikh Abdullah.
Ah, yes, that is a very, very good question. There is, in the UK, from a concrete temperature point of view, then, and I'm just talking generally in terms of all concretes in compliance with the standard, then the minimum concrete temperature is 5 degrees Celsius. That's concrete temperature. And the maximum concrete temperature is 35 degrees Celsius. So again, that's concrete temperature. Most low carbon concretes are slower setting. So I would say anything below 5 degree ambient temperature, 5 degree ambient, particularly when you get into the higher percentages of GGBS and fly ash, that would give me some concern about setting and stripping times. So around 5 degrees Celsius would be a fair assessment.
Thank you, sir. The next question is, higher fly ash contents can lead to more carbonation. How do you control this problem? And that was asked by Mr. John Abraham.
Higher carbonation, was that? Yes.
Yes.
Most concretes in the UK that contain fly ash would be around about 30% fly ash only. Typically the only time that we would move to higher percentage fly ash would be concretes in the ground, which of course are less at risk of carbonation because they're not in contact with the air. So there's normally around 30% fly ash when used in concretes in contact with the air. which is obviously a way of limiting the risk of carbonation.
Thank you so much, sir. The next question is, how can related the carbon content effect in concrete with HS2?
How can what, sorry? HS2?
Yes, sir. Yes, sir.
Could you just repeat the question for me?
How can the carbon content affect in concrete with HS2?
Right. Okay. So how are we looking to do it? So in terms of design, HS2 have a target to reduce by 50% for particular structural applications, and we're achieving that through higher percentages of GGBS. So there is a minimum of 40% GGBS in all concretes to be supplied to HS2. When we move into the geotechnical works, the piling, the diaphragm walls, the secant soft piling, then we're looking at 70 to 80% GGBS in order to meet those reductions in carbon targets. So it's concrete containing GGBS in order to reduce the embodied CO2.
Thank you so much, sir. The next question is, will the rate for low carbon concrete come down in future? And that was asked by Mr. Tony.
Will the rate come down? Well, as a concrete supplier, I hope not, because obviously we like to keep our prices high. But I think the more demand, once it's available in design standards and supply standards, I think once more companies are producing it, so the binder becomes more available, then a bit like most things in the construction industry, I would expect to see those prices reduce. The however is, as we've seen around the world in the last 12 to 18 months, the cost of production of construction materials is only increasing. So whether that's cement, whether that's reinforcement, all costs are going up. So I wouldn't necessarily see a dramatic reduction in price, but as the market opens up and more people are using it, then probably I would expect to see a small reduction in the price per cubic meter.
Thank you so much, sir. The next question, what kind of difficulties are you facing to implement the virtual ultra zero concrete? Also, are you able to provide the retentions required? And that was asked by Mr. Raghavendra DS.
Okay, sorry, what was the last point? So there was a challenge to supply it, and then are we able to supply what?
Are you able to provide the retentions required?
Right, okay, so I can certainly issue the associated documents. The biggest challenge with supplying Virtual Ultra Zero is the fact that it's a cement binder that's currently not included in design standards. So EC2, EN 1992, it's not currently included in BS 8500, which is the UK complementary standard to EN 206. So one of the challenges is trying to persuade clients, designers, customers, insurers to use a concrete that contains a binder which doesn't come with an associated British or European standard. So that's one of the challenges.
Thank you, sir. Next, we have a question asked by Hannah Fatima, and the question is, how does making concrete affect the carbon cycle?
Making concrete. So the production of concrete typically adds around 27 kgs of CO2 per cubic meter. So that's the production and the transport associated with the production of concrete. It's about 27, so about 10%.
Thank you, sir. Now we have one more question.
That's
and that
okay.
That is, do we have any specifications for low carbon concrete in India?
Oh, I don't know. I don't know about India. I don't know whether that's, hopefully somebody there could answer that. We don't have specifications for low carbon concrete in the UK. We have cement designations using fly ash and GGBS, which leads to low carbon, but that's one of the challenges, and it would be fantastic to work with the Concrete Institute in India to actually develop, and you can help us, we can help you to develop specifications associated with low carbon concrete. In the UK, we have something called PAS 2080, which is concretes containing geopolymers, concretes containing low proportions of SEM1, which I'm happy to share that document, but it's not a standard. It's what's called a PAS, so a public available product. So there's no specification in the UK for low carbon concrete. There's no number associated with it, nothing, unfortunately. But I think that will come. I think that will come.
Yeah, okay. Thank you, sir. Thank you, sir. Thank you for the wonderful question and answer session. And we are done with the questions, sir.
Okay, well, some great questions, and you know, again, I'm really, you know, really thankful for the invitation to present and discuss. As you can probably tell, I have quite a passion for concrete. I've been doing it for a long time, and you know, I'm really pleased to be able to talk to you guys about it. So thanks again for the invite, and I'll leave with the closing remarks.
Yeah, thank you, Richard, for the fantastic lecture, technical talk on low carbon concrete. Even though it's a new topic for us in India, but definitely all the points what you had put up in your slides was excellent, and I know that we all know that every country in the world has given a target to become carbon neutral by certain time actually. So most probably the governments, the people has to start thinking on this each and every aspect where we have to become carbon neutral actually, including the concrete. So everybody has to wake up, and each and every parameters where we do this concrete, especially the concrete industry, the cement industry, where a lot of carbon is emitted to the atmosphere, we have to start thinking how to do a good concrete with low carbon emissions, as suggested by your valuable suggestions are taken, and it will be circulated among all our interested participants. A lot of people are participating in this particular seminar, and a lot of questions also you get it actually. A lot of people are interested to know what is this about low carbon concrete actually. Thank you very much, sir. Thank you for coming on to our webinar, and which we have been conducting it continuously and with a particular interest on a particular topic. Every month, in a month, 2 or 3 times we come on to the for sharing the technical knowledge what you have. So thanks a lot for sharing the technical know-how, what is actually happening in the developed countries, to know, so that we can also start implementing, at least start thinking of doing the same actually. Thank you, sir. Thank you very much. Thank you.
Absolutely no problem. It's been a real pleasure. Thank you.
I also thank Indian Concrete Institute Mangaluru Center, Mr. Baliga, and chairman and EC members who has been continuously supporting QCrete Readymix in conducting this webinar successfully. And this is our 51st webinar, which has been doing. When we started this, it was the Corona time we started. Now it still continues with lot of audience coming on to the looking into this technical webinar actually. I thank Kaushik and Anjali also for coordinating this particular program, and last but not the least, all the audience who have been continuously supporting and giving us encouragement to do more and more such technical programs. Thanks a lot, and I'm Shelly Fernandez signing off from this webinar till we meet for the next with a new topic. Thank you very much. Thank you, Kaushik.